All right, good morning, everyone. Good morning. Good morning. Okay. All right, so I think we shall start without further ado. It's already 10:05. Before we start the lesson, I just have a few announcements to make. All right, so first of all, I have created a WhatsApp group, okay, for you to join. So, so please observe this rule. So this Wi-Fi code is available in the announcement section. So you can go to announcement, and then inside the announcements, you can see there is one discussion on WhatsApp group for ITS 66304. So you can go inside, and this is where you can find the QR code to join the group. Okay, so please observe these rules. Okay, so any question that you have regarding this module, please ask in the group. Do not personally message me on WhatsApp. But if you do have any personal inquiry, which is quite private in nature, you can use private message in My Times. So if you can see here, inside your My Times, there is this chat. Okay, so you can send your private messages to me via My Times. Okay, do not send it via WhatsApp. Okay, if you ask through WhatsApp, I will say please ask in the group. Okay, I will respond with ask in the group. Alright, so basically please observe this rule and practice this. And then observe the class rules again. Alright, so you can access the class rules here. So observe the communication mode. Alright, the time that I will be responding to your messages. I will not be able to respond to all messages all the time. Alright, so I would prefer if you submit or if you ask during the office hours. Alright, and then the last one that I would like to highlight here is the weekly plan. Okay, so some of you may, I'm not so sure, but plan to go to holiday or anything. Please observe the weekly plan, because we already shared this in the first week of the lesson. So you can observe when we are going to have our midterm test, okay, when you will have your final exam, okay, your presentation, and so on. So schedule your plan accordingly, okay, right, based on this weekly plan for this module. All right. And then another announcement that I would like to make as well. I know some of you have not yet attending your Lab 1. Okay, so for those who have attending your Lab 1, because a few students are having experience in installing the virtual machine and operating system, Linux. Okay, so I'm extending the submission for practical test or S1 to another week. Okay, so please submit latest by 13th of October. Initially, it was set to this Sunday, right? So I'm extending for another 1 week. So hopefully this can assist you to complete the lab and also to complete the homework that I asked you to do. Okay, so I hope it's clear. Right, so any question? Any questions so far? Okay, no questions, good. Okay, so I presume everyone understand what I'm saying here. Okay, so now let's look at the lesson today. Alright, so we will look at lecture number 2, process scheduling. Okay, I will open this in different. Okay, so basically, in lecture 1, you have learned about the important concepts and terms about operating system, alright? And in the tutorial as well, we have further strengthened your understanding about those concepts. So I hope with that you will appreciate your OS that you are using every day. Okay, so now we will look at how your computer schedule processes. You can imagine here in my tab, you can see there are so many tabs that I'm opening at the moment. And I can click any of this at any time I like. Okay, so that is one, Chrome. I can open many other Chromes, and then at the same time you see I have my Outlook here, I have my VirtualBox running, I also have my PowerPoint, and so many applications are running. So you might be wondering how your CPU is scheduling the execution of this task. How does it select what process to run? Okay, remember, you only have one CPU, all right? Or if you have many core, then you're going to have several processor. But it feels that the processor is executing all of this, right? But the real truth is your processor can only execute one process at a time. Only one. So the one that I activate here, this is currently in the processor. Okay? Any one that is not in the, that I do not activate, but is running, not running, but is ready. So they are all ready to be executed. So at any time, when I click the tab, okay, this one will go into processor for execution, right? Okay, so how, now we will look at the process in a bit more details, okay, and then we will see how your processor schedule the execution, right? So we call this uniprocessor scheduling because we are looking at only one CPU. We are not looking at parallel processing, okay? So this is just one processor scheduling task. All right, so basically from the previous lecture, all right, so we mentioned that one of the service provided by the OS is program execution. Okay, so the OS is responsible to execute programs. Okay, program is a processor basically. So when you want to execute a program, so resources must be made available to multiple applications. All right, so like this tab, I should have access to the keyboard, to the mouse, to the screen, and also to the processor. So these resources should be made available. And the processor will be switched among multiple applications. Okay, so all will appear sort of like they are progressing. Okay, they are being executed by the processor. Okay, so now we look at the process element. Okay, so for example, I just look at this tab. So this tab here is one process. All right. So there are two essential elements of a process. One is the program code, and another one is a set of data associated with that code. So what do I mean by program code? So this, the Google Chrome, okay, the application Google Chrome.exe, that is the program code. It allows the program to be executed in the system. Okay, and then of course when I open the Chrome, I can enter the URL. Okay, I can also open file. So that one is data. Okay, the data associated with that program code. Okay, so as simple as, for example, okay, your practical test OS1. So this application is the program code, and whatever that I type here, the document that I make, okay, that will be the data, okay, associated with this application or with this process. All right? Okay, so now process. Okay, if you go to your task manager, you can see a lot of processes. Okay, so for every process that is running inside my machine, okay, each process will be uniquely characterized by a number of these elements. Okay, so every process will have an ID, identifier. All right, it also have a state, what state it is currently in. Okay, priority, whether it has high priority, low priority. Okay, program counter, okay, the location of the start of the location where the program is in the memory. Okay, the starting location in the memory. Memory pointers, context data, the user data, I/O status information, whether the process needs to use I/O or not. Okay, and then accounting information. Accounting, remember, yes, this week you learn about accounting. What does it do, accounting? Collect what? Okay, like what? Just few days ago. Come on. Final exam is in week 18, week 15. If you forget now, you will forget soon, later. Okay, accounting, meaning it collects the usage of resources by the process, and it will monitor how the process performed. Okay, that one is accounting. So all process will have this information, okay, associated with it. Okay, this information, okay, will be stored in the memory as a process control block. We call it process control block. So every process will have this block. Okay, so this block basically contains all the information that I mentioned just now. So all this information will be stored inside a main memory. Alright? Okay, so it contains the process element, and then it is created and managed by the operating system. So this process control block is the key tool, okay, to allow the operating system to execute multiple processes at one go, right? Okay, so now the process states. Process can be in several states, all right? But before you know what are the states, okay, you might want to know these two concepts first, trace and dispatcher. Okay, trace. What do you mean, what do you understand? Trace, normal terms, daily life. Let's say you forgot where you put your car key, then you try to trace your car key where you put it. Then you start to recall where you have been, okay, what things you have touched before, so that you can recall where's the last place you place your car key. You are tracing your car key. Alright? So it's the same thing like tracing here. So tracing here, okay, for every process, there will be a process trace. So what does it do? Okay, it will list down the sequence of instructions that execute for that process. So what are the sequence of instructions that has been executed and will be executed for that process? So that's what we meant by trace. Okay, list of instructions sequence, right? And then we have dispatcher. There will be one element in the processor and also in the operating system to dispatch. Okay, so this is a small program that switches the processor from one process to another. So when I click the tab here, and I open a different program. So it is done by the dispatcher. So the dispatch will, will change, okay, the process that we run in the processor. So that's meaning of dispatch. Okay, send in and send out. Okay, so that is dispatcher. So these are the two main components. Okay, they are essential. Okay, when we talk about process, all process will have tracing, and it will be handled by dispatcher. Right? Okay. So, for example here, and inside the PCB just now, process control block, if you go up here, you have this element called program counter. Okay, program counter. So what this program counter is? Okay, program counter basically points to the first location where your program will start in the main memory. Okay, so this is your main memory. Okay, all memory has, every cell in the memory will have address. Okay, so this is the address. And in the main memory, you will allocate some space for the programs. Right? So for example, of course, the dispatcher, the one who dispatch what program to be executed, okay, there will be one space here for dispatcher. Okay, and then here you have, let's say, 3 processes, process A, B, and C. So all of them will have the starting address. okay, in the main memory. Right? So let's say if I want to execute process A, my program counter should contain 5,000. So in this case, in this example, your program counter contains 8,000. So 8,000 means it will point to the beginning of process B. So it means that currently your processor is executing process B. Okay? Right, so program counter, remember, the function of program counter is to point to the starting location of a process in main memory. Okay, so that is program counter. So once you execute, okay, you can see within your main memory, okay, once, okay, let's say for example, process A. Okay, so process A start at 5,000. So you can see here, process A start at 5,000. And below that, okay, the consecutive numbers or address are referring to the list of instructions that will be executed for that process. So meaning that for process A, the instructions for process A are stored between 5,000 to 5,011. So that will be the list of instructions for process A. Process B, for example, the instructions are only 4 instructions. Okay, so it is starting from 8,000 to 8,003. And for process C, it has similar number of instructions as process A, and the instruction starts at location 12,000. Okay, so this is what we meant by tracing. Traces, list of instruction sequence, okay, that will be executed for that process. Okay, so you can see here. All right, so this is a sample of execution, okay, and we combine the trace here. All right, so for example, I just illustrate to you how this example works. Okay, let's say the processor first job that it does is starting from number 1. Okay, 1, 2, 3, 4, 5 until I think 46. So it execute process A first, starting from location 5,000. Okay, 5,000, 5,001, 2, 3, 4,004, and 4,005. Okay, and then let's say process A wants to use some I/O, or you just switch the tab. You activate another program. Okay, you activate process B. So there you can see before the processor can execute process B, you need to dispatch first. The dispatcher will be activated. Okay, so you can see your dispatcher is located at this location, starting from 100. Okay, so before the processor can execute process B, you have to call the dispatcher first. Dispatcher, come in. Okay, can you remove process A from processor and bring in process B? Okay, all right. So you call out dispatcher, so dispatcher will be executed, and then now the processor will execute process B, starting from 8,000. Right? Okay, so starting from 8,000, complete once, let's say here process B wants to use some I/O. Okay, and while waiting for the I/O to complete, then you activate process C. Okay, starting from address 12,000 here. And of course, in order to switch between program, again, you will call dispatcher. Okay, dispatcher come in, and then remove process B, and bring in process C into the CPU. Right? So you can see here. Right? Timeout, complete execution of process C. Okay, now you want to go back to process A. Right? So again, you call the dispatcher. Okay, so remove process C and call in process A, and the steps will be repeated accordingly. All right? So you can see this is the trace of combined processes. Okay, between process A, process B, process C, and also the dispatcher. Okay, the one that you see here. Okay, this one. Right? Okay, clear? before I proceed. This is about trace and dispatcher. So it is important for you to understand these two concepts first before I move on to the scheduling. Alright. Okay. Now, let's look at the state. So one of the information inside the PCB, process control block, is state. Okay, so I show you a 5-state process model. Of course, a different operating system, for example, Linux and then Macintosh, Windows, they might have a different model. But what I discuss here is the generic one, that most of the operating system is adapting this one and they may be enhancing this. Okay, but this is the basic model. Okay, you have 5-state model. What does it mean? It means that a process can be within this either one of these states. Right? So basically, nothing, and then you create the process, so it becomes new. Okay, you got new process. So what is this new? New here. Okay, new here refers to a process that has just been created. You just double click the process. Okay, now you start to see your cursor turns into, executing. So that one is new. Okay, but has not yet been admitted to the pool of executable processes by the OS. You just start. You just double click. So that is new. Okay? Alright. So from new, okay, once you see your mouse stop splitting like that, okay, so it means that now the process that you just double click has been admitted into ready. They are now being placed in the ready queue. Okay? Okay, ready queue. So ready means a process that is prepared to execute, okay, when given the opportunity. Alright? Okay, so ready. So from ready, okay, from ready here, there's only one way to move forward. There's no other way. Okay, which is to be dispatched. Okay? Dispatched by the dispatcher into running state. Okay, running means the process that is currently being executed by the CPU. Okay, so running means that process is currently inside the processor. So the dispatcher will dispatch, okay, between the process in the ready queue and bring into the processor. All right. So from running stage, where do you can go to? Okay, you can the process can either go back to the ready queue because of timeout, okay, or you finish the execution, you close it, exit, okay, you terminate the process maybe, or it can be blocked, events blocked, okay. So this one is referring to the event wait block. For example, the process wants to use a specific location in the memory, but the memory at the moment, that location is occupied by another process. So that running process will be blocked for a while. Okay? And then from blocked, after the resources or the event occurs, then it will be placed back into ready state. Okay? So this is the 5-state model. This is the simplest version. Right. So what are the reasons for process creation? Okay. A new batch job, you just create a new batch. Okay. Or one user login into the interactive system, like MyTimes, you log in to your account. Okay. Or it was created by OS, okay, to provide a service. Right? or it was spawned by the existing process, okay, due to the modularity and so on and whatnot. Okay, for example, from your PDF, you can open a Chrome, a link. So that one is spawned by existing process. Okay, right. Termination. Terminate. Okay, you want to terminate the process. There are quite a number of reasons why a process can be terminated. So here in the following slides, okay, there is a list of reasons why a process can be terminated. Terminated here means it moved from running to exit just now. Okay, if you look at the state here, running to exit. Okay, all right. Okay, so far any question on the process? Any question? Okay, it's clear, it's good. I hope it remains here long enough until tutorial next week. Okay. Alright, so now we will look at the scheduling. Okay, so scheduling. So now you want to see what are the decisions used to decide which process, okay, goes from ready to running. How the dispatcher dispatch the process to be executed, right? So that's what we meant by scheduling here. Okay, so when we talk about scheduling, okay, its aim is to assign processes, okay, to be executed by the processor, okay, in a way that meets the system objective. Okay, so it depends on what the system wants. Okay, if it is about response time, then the decision to choose which process to be executed will be different if the objective is about throughput or processor efficiency. Okay, so but the main idea here is that the system will have some objective that it wants to achieve. So how the decision is made will be depending on that objective. Okay, so there are three separate scheduling functions: long-term scheduling, medium-term scheduling, and short-term scheduling. Okay, so long-term, okay, the decision to add to the pool of processes to be executed. So you can see here, this one is long-term. From new to ready. This one is using long-term scheduling. Okay, and so this one, okay, new to ready, suspend, or new to ready. All right. Okay, and then we have medium-term scheduling. Okay, the decision to add to the number of processes that are partially or fully in main memory. Okay, the one is medium-term. Okay, this one. So the process has been suspended. Okay, so now you want to bring it back into ready state. Yes. Oh, yes, suspended just now. For example, when a process, let's say, wants to use a specific location of the memory, but that location at the moment is being utilized by another process. So it needs to wait. It needs to wait for another process to release that space. Then I can come in, then that process can come in and use that space. So basically, there is a certain condition where the process will be suspended for a while because it cannot continue the execution due to availability of resources. Okay, understand? Right, so that is suspend. Suspend here, I think the book is not consistent. Suspend here refers to the, if you go down here, blocked. Blocked. Right, and then we will look at the short term. Okay, short term is the decision as to which available process in the ready queue will be executed by the processor. So you can see here, this is where your short-term scheduling is. Okay, so there are three levels of scheduling: long-term, new to ready; medium-term, blocked to ready; okay, and then short-term, ready to running. Okay, right. So now Okay, this is just an illustration for that. Okay, so I will focus on the short term. Alright. Okay, short term here, short term scheduling is also known as the dispatcher. The dispatcher itself is basically a short term scheduler. Alright. And this is the most executed function in the OS. Because remember, here in my tab, I have so many things. I click, click, click so fast. So the dispatch must work fast as well. And this is the most frequent operation executed. So it is invoked when an event occurs, okay, to decide which processes need to be executed by the processor. Okay, so how to decide which process to be executed? Okay, it depends on certain criteria. Okay, so the criteria can be classified into performance related or non-performance related. Okay, whether you want to have a higher response time and throughput, or you want to have a better predictability. Alright, so these are some performance related measures. Okay, so the two measures that you need to focus on for this course, you don't have to study to focus on everything here. I mentioned to you that you just need to focus on the first two: turnaround time and response time. Okay, we will measure this, okay, for the scheduling. Alright, so the rest is an additional parameters that you might want to explore. Okay, so we will study 4 types of scheduling for this course. Okay, in the table we have 6, but I just want you to focus on the first 4. FCFS, round robin, SPN, and SRT. So what are they? Right. So basically, the selection function will be based on the algorithms that you use. Okay. So there are, when it comes to decision as well, there are 2 modes of operation. One is non-preemptive, another one is preemptive. So you have non-preemptive scheduling algorithms, and you also have preemptive scheduling algorithms. Non-preemptive means when the processor is running inside the CPU, no other process can go and push it out from the CPU. So the CPU must complete executing until the end. Okay, so that is non-preemptive. Preemptive means, okay, if there are certain criteria met by a new process, that new process can kick out, okay, the existing process from the CPU. So that is preemptive. Okay, you can change the process running in the CPU. Now, let's look at the first example. I wish I can use this, but I don't know how to use this anyway. Okay, so let's say here we have 5 processes. Okay, process A, B, C, D, E, and this is the arrival time 0, 2, 4, 6, 8, and this is the service time. Service time means execution time, processing time. Okay, 3, 6, 4, 5, 2. Okay, maybe I can create a new file. And then the name service time here, execution time 3, 6, 4, 5. 3, 6, 4, 5. Alright. So now we will look at how these algorithms work. Okay, can you see? Alright. So let's look at the first algo. Okay, so I give you in this diagram, in this figure, all the execution timeline. This is what you need to know. This is what you need to draw as well. Okay, so for every algorithm, given this set of processes, how it will be executed by your processor. Alright, so we will discuss FCFS, first come, first serve. We will discuss round robin. Okay, round robin has different quantum time. We will look at the different for different quantum. And then you have the shortest process next. Okay, shortest process next. And then you have the shortest remaining time algorithms. So the rest is optional. Alright? Okay. And then for each process scheduling here, you will also learn how to calculate the turnaround time. Okay, so what is turnaround time? Okay, let's look at the definition up here. Okay, turnaround time, this is the interval time between the submission of a process and its completion, including the actual execution time plus the time waiting, spent waiting for the resources. So this is the turnaround time. Okay, this is the only parameter that I would like you to calculate. Alright, so let's look at the FCFS first. Okay, so you can see here. First come, first serve. Okay, this is the simplest scheduling policy. Okay, it is also known as first in, first out. Okay, what does it mean here? When the currently running process stops to execute, the process that has been in the ready queue the longest will be selected for running. So it will be based on the ready queue. So which process that has been there the longest, that one will be selected for the next execution. So that is the rule. That is the decision rule. Okay, for FCFS. Right, so now let's look at this diagram here. Okay, so you can see process A come first, right? At time 0, arrival time 0. So definitely process A will be executed first. For how long? As the processing time is 3. Okay, for maybe 3 seconds. Okay, so 3 time units. Right. And then process B comes at what time? 2. Okay, so you might want to create a ready queue here. So this one will be helpful for you if you create a ready queue. Okay, at time T0, B comes in. Okay. B process. Okay, T2, B comes in. All right. Okay. So meaning that, and then so you can see here at time 3 here, B starts to process lah because B is in the ready queue already. All right. So then you can remove the process from your ready queue. All right. And then, okay, at time 4, while B is executing, who comes in? C. Okay. At times T4, C comes in. Okay. C comes. Okay, but because FCFS is non-preemptive, so C cannot kick it out. So C has to wait until B completes the execution. Okay, so B will execute for 1, 2, 3, 4, 5, 6. Okay, and then by the time here at 9, who is in the list, in the ready queue? So if you can see here, D as well and also E. Okay, all right. So at time 6, you have D. At time 8, you have, at time 8, you have E. Okay, so the selection, now in your ready queue, you have 3 processes, am I right? 3 processes. So which one do I need to choose? I choose the longest one in the ready queue, which is C. C has been waiting for so long. Okay, so then I take count C, and then the next one in the queue is D. So I execute D. And then here, the last one is E. Alright, so I execute E. So this one is first come, first serve. Alright, so now let's calculate the turnaround time. Okay, turnaround time, so this is your process A, this is the service time TS. Okay, so to calculate the turnaround time, you observe the finish time, when the time is finished executed. Okay, so you can see here, for process A, it finished executed at time 3. Process B, finished executed at time 9. Okay, process C, times 13. Process D, 18. And process E at 20. Alright, so now turnaround time. Turnaround time means the time from the time it arrived until the time it finished execution. Alright, so what you can do is that you can deduct this number with the arrival time. So 3 minus 0, you get 3. 9 minus 2, you get 7. Okay, 13 minus 4, 9. 18 minus 6, 12. Okay, and then 20 minus 8, 12. Okay, the time it arrived until the time of completion. That is turnaround time. Okay, and then you calculate the mean. Okay, the mean for the turnaround time. Okay, all right. Okay, TRTS is the response time basically, but I want you to focus on the turnaround time. Okay, okay, so now let's look at the next one, round robin. Okay, so round robin, it uses a preemption, meaning that a process can be kicked out from a CPU if the condition met. Alright, so this round robin is based on the clock. Okay, we call it quantum clock. A clock interrupt will be generated at a periodic interval. So for example, if I set the clock every 3 seconds, then every 3 seconds the clock will interrupt the CPU. And it will kick out that process and bring in a new one. Okay, so that's what happened. So this one also known as time slicing. Okay. The principal design is that the length of the time quantum or slice is to be used. Right. So when the interrupt occurs, okay, the currently process is placed in the ready queue and the next ready job is selected based on the first come, first serve basis. Okay, so now let's look at the example. So here I give you 2 examples. Okay, for round robin with 2 different quantum number. Quantum number 1 and quantum number 4. So quantum here refers to the interrupt timing. Okay. So quantum number 1, it means that the CPU will be interrupted every 1 cycle. Quantum time 4, it means that the CPU will be interrupted every 4 cycle. Okay, every 4 cycle it interrupt the CPU. Okay, so this is the difference between, this is about the quantum time. Okay, different value has different meaning. Okay, so now let's look at quantum round robin quantum 1. Okay, so this is preemptive. So you can see here. Okay, I think let's make another round robin here. Okay, so again, prepare your ready queue. Okay, all right. So now let's look at round robin quantum 1 first. Okay, quantum 1. Okay, so the one in the first arrive is A. So A will be executed. At time 1, okay, the CPU will be interrupted. Clock interrupt. Okay, do you want to change? Do you need to switch any process? In your ready queue, there is nothing yet. So let's continue executing A for another 1 cycle. Okay, and here, all right, here at time 2, B comes in. All right, so after the second clock cycle, alright, check the ready queue. Is there anything in the ready queue? Yes, we do. We have B in coming. Alright, so now let's preempt A. Kick out A and execute B in the ready queue. Okay, so there you can see here. So now the processor will kick out A, put it back into the ready queue. Okay, so at time 2 here, A kick out with the remaining processing time of 1. Okay, just take note how many left, right? And then let's execute B. Okay, so you can see. Then the processor will switch to execute B. Okay, so it execute B. Okay, and then, okay, after 1 unit, time unit, let's see. Is there anything in the ready queue? Yes, we do have process A. Right, so let's switch. Okay, let's switch. So switch from B to A. So meaning that each process can only accommodate the CPU for only 1 times unit. So if it is 4, will be 4 time unit. Okay, so then it will switch. Okay, now let's put back B here. Okay, with the remaining time, I think 5. Okay, and then let's execute A. Alright, so it will repeat this process until the end. Right, so quantum time 4. Okay, so it means that the changes will only occur when at every 4 time unit. But of course, because A is shorter than 4, then it would happen earlier. Okay, so this is the concept of round robin. Right. Okay, and then we do have shortest process next. Okay, so this is non-preemptive. Okay, non-preemptive means a new process cannot kick out the current one. And the process here, the choice of what process to choose next will be based on the process with the shortest expected processing time. Will be selected next. Who has the shortest processing time? Okay, alright, the short process will jump to the head of the ready queue and that one will be selected. Okay, so you can see some example here. Okay, alright, and the last one that I want to highlight here is the SRT. Okay, there's some information. SRT, this is the preemptive version of SPN. Alright, so what does it mean? It means that the scheduler will always choose the process that has the shortest expected remaining time. How much more time left for execution? Okay, and here is some example. Alright, I will not be able to discuss all of this within 1 hour. Okay, I need 1 more hour to discuss this. Alright, but anyway, inside your My Times, I just prepare 1 exercise for you to do at home. You can go to the forum. Okay, there is one here, exercise lecture 2 scheduling. Okay, you can click on this link. Okay, read again the scheduling algorithms and then try to draw the timeline. Okay, and also calculate the turnaround time. Right, we can always chat in the WhatsApp. Okay, if you need any assistance or guidance, then we can communicate in the WhatsApp. Right? Okay, so far any questions? So before I end the session, okay, so let's update the attendance. Right, and feel free to ask questions. Okay, for the lab, if you do have or face some problems, please screenshot your problem and put it inside the WhatsApp group. Okay, I'm pretty sure each one of us will be able to help your friend as well. Okay, our friend. Okay? Alright, so with that, I will end the session and I will see you all next week. Yes? I mentioned just now. you can look at the due date. Okay, the due date for lab number 1, practical test OS1 has been extended until 13th of October.
So it's personal, not group.
Yes, personal. This is individual. This is individual assessment, not group assessment.
So the practical also is, the lab also is personal, not in group member.
You will have group assignment later. So group assignment, I will release this in week 5. That one you have to form a group.
So the lab not.
This one not group. This is practical test.
Also is the practical, not assignment. I mean, do the practical.
Yes, correct.
Okay. Okay.
Practical. All right. Did you attend your practical session?
In this afternoon.
This afternoon, Mr. Chu. Okay, then Mr. Chu will tell you. All right. Yes.